All right, let's keep talking about exponential modeling. Today we're going to talk about modeling with percent increasing and percent increase and percent decrease. So let's review a little bit about percents here, so that'll help us when we come time to actually writing the equations and the models. So number one says, by definition, a percent is a fraction with 100 as the denominator. So to find a percent of a value means you multiply that number by a fraction. So let's see, if I'm finding 22% of 80, well, I'm going to take the number 80, and I need to multiply it by a fraction. Now, 22 as a fraction is going to be 22 over 100. Okay, so if that is what I'm multiplying together, I'm going to take my calculator, and I'm going to take, whoops, there we go, 80 times, then we'll have our fraction, 22 over 100, and I get 17.6. Okay, so that would be how you find 22% of 100. Now we can avoid using the fraction and still calculate this percent. So let's turn 22 over 100 into a decimal. Well, I'm just going to use the box underneath. 22 over 100 is 0.22, 0.22. So if I instead take 80 times 0.22, it should give me, 17.6. It should give me that same answer. So let's try it. If we take 80 times 0.22, and it does, it gives me 17.6. So in this unit, we're not going to want to use fractions for our percentages. We're going to want to use decimals. It's going to make things cleaner and easier to type. All right, so let's spend a little bit more time here. If I want to find a percent of increase, I'm going to add that percent back onto the original value. If I want to decrease by a percent, I'm going to subtract that amount from the original value. We can do this in one or two steps. Ultimately, we're going to do this in one step, but I'm going to get you there first by showing you the two-step method. It says you need to pay 15% tax on a car that cost you $12,000. So here's the two-step method, right? Step one would be to find the 15% of tax. So you're going to take your $12,000 and multiply it by 15% as a decimal, right? So this is going to give me the percent of tax. Okay, so I'm going to take 12,000 times 0.15, 15%. And that tells me that the tax I'm paying is $1,800. Now, step two here is going to be to take the original cost of the car and add the $1,800 tax that we just calculated. So 12,000 plus 1,800 is $13,800. That's two steps. I found the tax, and then I added it back on to the original cost. Now let's do a one-step method. Here's how it works. I'm going to take the original value of the car, and in the parentheses, I'm going to put 1 plus the percentage that I'm adding, which is really 1.15. I'll show you on decimals here. That's the one-step method. So let's calculate. So if I take 12,000 times 1 plus the percent of tax, I get 13,800. And I can do the same thing if you don't want to write the plus sign as just 1.15, because that's 1 plus 0.15 is 1.15. That's where I got the second one from. It gives me the same answer, so it does not matter which one you choose. Oops. So it turns out that the one-step and the two-step method both give me the same answer. The two-step method is a little bit faster because there's a little less calculating to do. Now, the hardest part is remembering the one and the adding and the subtracting. So we're going to do lots of examples here. And hopefully after you do a bunch of examples, you'll get the hang of percent increase and decrease. So let's start here with the one-step method. You go out to dinner at a fancy restaurant and the bill is $68. You want to leave an 18% tip for the waiter. How much in total do you pay? So with your bill and the tip. So here's our one-step calculation. I'm taking my bill, $68. I'm going to multiply it by 1. Now, when I leave a tip, that adds on to my bill. So 1 plus the 18% tip. Right, so I'm going to take 68 times my, I'm going to do it this way, 1 plus 0.18 tip. And that means you're going to leave a bill, or you're going to leave in total $80.24. Let's try vegan meals at Tofu For You, are on sale for 30% off. That means less. The mixed bootable is $8.50 originally. How much is it on sale? Well, if I'm on sale, that means that $8.50 is going down in price. And we said that if you are going down with percentages, you need to subtract a percent from the original value. So what you'll have here is you're going to write 1 minus the 30% as a decimal. So 8.5 times 1 minus 30%, which is $5.95. So the mixed bootable is $5.95 on sale. Now really quickly before we move on, I've been writing 1 plus 0.18, which we agreed we can write as 1.18. If you wanted to, you could write the plus sign. And 1 minus 0.3 would be 0.7, which you can write the minus sign, or you can write the 0.7. Now we're going to be getting to exponential increase and decrease. So remember just a little bit what you know about exponential functions. If the number in the parenthesis is greater than 1, it's increasing, which is true when you're leaving a tip, the value's going up. The number in the parentheses here, if it's decreasing or less than 1, the value is going down, which is what we saw when we're on sale. So it's all kind of connected here mathematically. All right, last one, then we'll do some modeling. You have a Visa card and the balance is $522. Visa charges you a percentage of the balance each year in exchange for you borrowing money, right? They don't just magically have the money, they're loaning you money for your credit card. It's called your APR, the annual percentage rate. That's the tax you have to pay if you don't pay back your loan. So your APR is 12%. If you do not pay off your credit card at all for a year, how much will you owe after 1 year? Well, you'll take the $522. Now this increases your bill, so we're going to do 1 plus 0.12. So if I have 522 times 1 plus 0.12, that means after 1 year you would owe $584.64. Now here's the thing, say you don't make any payments still for a whole nother year. How much will you owe at the end of 2 years? Well, your new current balance is at $584.64. That was your balance after 1 year. Now they're charging you interest on that, and it's still 12% interest. So when I calculate this, I'm going to take the $584.64 and now multiply that by 1.12. And now you owe $654.80 when you round. So after 2 years, if you don't pay anything, you owe over $130 more just because you didn't pay off your bill. Well, now that we've reviewed percent a little bit, let's shift our focus to modeling and doing percent increase and decrease more than just one time, right? We've just been kind of like, okay, you didn't pay your bill for 1 year, or it was on sale one time. What if this happens over and over? So these models, you're really not any different. They make it look more complicated than it is. Remember, your general exponential model is a times b to the x. That is exactly what I have highlighted here. It's just written differently. This a sub 0 is your a. The 1 plus p is your b. A and b. Same thing. The 1 plus p means when you're increasing by a percent, you take 1 and add the percent, p, to it. And when over here you're decreasing, you're going to subtract the percent. It's easier to see just by throwing you into an example. Write an equation that gives your savings if you invest $250 at an interest rate of 3% every year. Then figure out how much money is in the account after 12 years. Well, if you have an interest rate of 3%, that means that you are increasing, going up. So, we're going to write a model. The amount of our savings is, it starts with $250. Now, because we're increasing by a percent, we're going to use this idea of 1 plus the percent. Now, 3% as a decimal is 0.03. And we want to know after 12 years, that's our exponent. So when I type that into decimals, I'm going to take 250 times 1.03, and my exponent is going to be 12. And after 12 years, it looks like you'll have $356.44. Let's try another one. Example 2. Population of the town is decreasing by 4% every year. And it starts with 12,500 people. What's the population in 10 years? Well, if you're going down, you have to write the amount you start with, which is 12,500 people, and you're decreasing. So we're going to take 1 minus the percentage decreasing by. 1 minus 4% as a decimal, right? After 10 years, so to the 10th power. Now, if you wanted to, you could write 1 minus 0.04. That's 0.96. And there you can see 0.96 is less than 1, which is why this model is decreasing. All right, so let's type this into decimals and see how many people there are in 10 years. 12,500. Type it too many. There we go. Times 1 minus 0.04 to the 10th power. It looks like to the nearest whole person, there's about 8,310 people left. So after 10 years, you only have a little over 8,000 people left in the town. All right, the next one, given the model, it says determine the growth, whether it's growth or decay, and then the percent increase and the starting amount, or decrease. Well, because I have this model here, 0.8 is less than 1. So this is percent decrease. The starting amount is the first number you see in your equation, which is 200. The percent of change, so the percent of decrease or decay, since we're going down, the way we find this, it's not 80%. Don't write 80%. The way we got 80 is we did 1 minus some percent. So I'm going to figure out 1 minus 0.8. And if you need a calculator, go ahead. And you could do 1 minus 0.8. And you get 0.2, which is 20%. You're decreasing by 20%. Right, if I took 1 minus 0.2, I would get 0.8 in my parentheses here. That's not the percent you're going down by, it's the 20% you subtracted. Last one, then we'll do some practice. From 1991 to 1995, the number of computers per 100 people was modeled by this equation. So the first problem is, what's the initial amount of people who had computers? Well, that's that 25.2. So the starting amount, or the initial amount, is 25.2. That means 25.2 people out of 100 had a computer. Right? So about 25% of people in 1991 had a computer. Okay? The percent of increase, well, I look at this number here in the parentheses. It's 1.15, which is going up. That's 1 plus 0.15. So if I want to know the percentage increase, I'm going to ignore the 1 and look at the number after the 1, the 0.15, which is increasing, percent of increase, by 15%. If you're having trouble with that, ask your teacher. It's a little bit harder to show on a video, but I can show you pretty easily one-on-one. Now use the same model they gave you to find the number of computers in the year 2000. Well, we started in 1991, so the year 2000 is 9 years after 1991. So we're going to find for T9. So the number of computers in year 9 is 25.2 times 1.15 to the 9th power. And you can go ahead and type that into Desmos. Here we go. And it says 88.65. So that means out of 100 people, 88.65, let's do per 100 people, have computers in the year 2000. So you go, in 9 years, you go from about 25% of people to 88% of people having a computer. All right, that's it for the notes. I want you to try to practice on percent increase and decrease. If you have questions, check the key on Canvas or ask your teacher for some help.